South Africa, and Chile. These are to be located on the globe. So these are also called the countries of a southern continent because Chile, South Africa, Australia, they are located in to the south of equator. So the continents which are at the south of equator are called as southern continents. So these nations we call southern countries, also called countries of southern continent, as they are in continents which are located to the south of equator, right? And in these countries, the cycle of the seasons is different. They have winter when we have summer. When we have winter, they have summer. So this is the pattern in all the places to the south of equator. Uh, we experience that one. It means that the nations, the countries which are to the south of equator, when they experience winter, we experience summer. Okay, this is the thing we see here. Understand? Here, we are not only ones with such questions. There are several years onwards, thousands of years, human beings have been interested to know the matter about over time. They worked out to find out the answers. So let us try some of the points which leads to the seasonal change. Why some parts of the earth are warmer and some other parts are cold? Why the seasons are opposite in the northern and southern hemisphere? These are the some questions we need to answer here, right? So here there are some factors which influence the seasons. Dear students, they are human beings from thousands of years onwards. They have been working on identifying the reasons for change of the seasons. So in their experience, they have identified some reasons that we call factors of seasons, factors which affect the seasons. Instead, there are some factors which affect the seasons. Instead, what are those? Here we see that there are some factors which influence the season. To understand this, we have to understand the interaction between several factors. That is a spherical shape of the what to call a earth and the curvature of its surface. This is one factor. The first one, the spherical shape of the earth and the curvature of its surface. This is one factor. Second is a daily rotation of the earth on its own axis. Third is the tilt of the axis of rotation compared to the plane on which the earth moves. The fourth is the earth's movement around the sun once a year. That what we call revolution. So let us see that each and uh, each and every one, that four factors which influence the season, right? The first one is the spherical shape of the earth. Earth is in spherical shape. So what happens when earth is in spherical shape? There we see that the insolation received by earth will be different from different at different places, right? Here there are some factors. Look at this what you call figure 3.2. This is the spherical shape of the earth. Understand what is this spherical shape of the earth? Look at, my dear student, this is a spherical shape of the Earth. Understand? So here the spherical shape of the Earth is one of the factor here. How when it is spherical shape and curvature of the Earth. What is mean by curvature? It is a what you call the line is not straight, it is a curved line, right? If you look at the shape of the earth, you will find always in its shape there is a curvature, right? That is curved line in its boundary line. I'll show you that, keeping the dot. See, this is what a curvature bent is there, right? So the spherical shape of the earth and its curvature will cause the insolation to be different at different places, right? Here the heat is not distributed similarly throughout the earth's surface. Some regions are heated very much and some other regions are very less, right? This is the fact we already studied, that is the places which are near to equator will near to equator will be warmer than the places far from the equator, that is near to the poles, right? Why at equator the sun rays fall vertically? It's a flat area. There the sun rays fall vertically. Beyond this limit, that is Tropic of Cancer and Tropic of Capricorn, beyond these two latitudes, sun rays fall diagonally, not straight. Over the head, sun rays does not fall. Right? Diagonally, sun rays fall after the Tropic of Cancer and Tropic of Capricorn. So that what happens when sun rays fall diagonally, they cannot reach the what to call the area of the earth's surface. Some of the rays may pass over beyond the earth, right? And when sun rays fall diagonally, it covers a larger portion. Here you see that, dear students, the large portion has to be covered. This is the area. If sun rays are falling here, you will see here, just I'll show you what here, this is our earth, right? If the sun rays fall, what you call when sun rays fall diagonally here, understand, like this, just a minute, in this way you'll see that like this sun rays fall, so that the area here is much larger, right, than the area near equator. Here sun rays fall vertically, understand, so that we see here that the curvature nature of the earth will influence insolation received there, right? Insolation received a place decides the temperature there, right? So the temperature when is different from one place to another place, it will bring a change in the seasons. Understand? So the curvature, nature, and the spherical shape of the earth we discussed in lower class. That is yesterday, so 2 days back. That the distribution of heat over the earth's surface is different at different latitudes, right? At equator, sun rays fall vertically, so there the temperature is high, it becomes summer, right? Tropical zone. Going to north pole or south pole, sun rays fall vertically, so there it is colder than the equator. So due to the temperature difference from equator to north pole or south pole, we observe that the seasons are taking place. Understand? This is one of the factor which brings change in the seasons, right? Second is Earth's tilt and revolution around the sun, right? See, the Earth rotates and goes around the what you call sun, right? Like a top spin. How you use a top to spin it in the same manner, Earth rotates around one imaginary line. Here you can see that on the North Pole there is a small vertical line here, and it's the south. So there is a one imaginary line passes through the middle of the Earth. This is called axis, my dear students. We call it a axis instead. So it is an imaginary line. So Earth rotates around its axis, right? That is an imaginary line connects the North Pole and South Pole, right? So this line, the imaginary line connecting North and South is called axis. So Earth rotates around this imaginary line, understand, and that is called Earth's rotation. Okay, the what you call the rotating or the Earth rotates. The rotation of the Earth around its axis is called a rotation. So all parts of the Earth go around this line once in a day, right? It means that in 24 hours, 12 hours day, 12 hours night, right? So in 12 hours a day and 12 hours a night, which is 24 hours, it will take to complete one rotation on its own axis instant. So the earth rotates around itself, that is around its own axis. So while rotating, it takes 24 hours to complete one rotation, right? It moves from west to east, dear students, instant. In which direction it moves? West to east. This is west, and here is east. So it rotates from west to east in this direction, west to east in this direction it rotates instant. So when it moves from west to east, okay, our globe is facing you, it rotates from your left to the right. Understand what I am saying? It is from earth rotates from west to east, right? So western portion moves towards east. This is the western portion, dear students. This is the western portion. It this western portion moves towards east. Understand? That is what you call rotation, west, moving from west to east. This is east. Understand? So in that way, our Earth rotates from west to east. So this is the reason why the sun, the moon, and the star appears to rise in the east and set in the west. Right? You know, when Earth rotates from west to east, we will identify that the sun is rising in the east. Understand? Actually, what to call, our earth is rotating so that we feel that the sun is rising in the east instant. So this is of course that what you call an illusion. This is created by eastward spin of earth. The first and foremost effects of the earth's rotation is a daily alternation of day and night. See, when it rotates from west to east, some part, that is off part of the earth, will expose to the sunlight. So that is to be called day. On that area of the earth, it is day. and remaining part, that is another half part of the earth, will be in the dark, opposite to the sunlight. The earth area on the earth is called night. Instead, in that way, we see that day and night occurs by the earth rotation. Dear students, I'll show you here. Look at here. This is what you call east, and it is west, right? So when it is rotating from west to east, we see that the sun rays first fall on the east, right? As the western portion comes to the eastern side and the eastern portion is coming towards west, then the eastern portion will expose to the sunlight first, so that the eastern portion will get sunlight, that what we call day, and the western portion will be in the dark opposite to the sunlight, so that it will be night. So, what are the effects of the earth rotation? Day and night, day and night, and in their variation, right? From early morning to afternoon 12 o'clock, what do we see? Gradually, the sun position changes. When 6 o'clock, what do we see? The sun in a horizontal position, right? It means that rising early morning. By 12 o'clock, we see that the sun is over our head. It means that the sun rising from the east and moving towards west as earth rotates. So in its rotation, we see the part of the earth which is exposed to the sunlight will vary at every moment, so that the duration of the day and the duration of the night, for every moment it changes, right? So that we call it day and night is occurring by the Earth's rotation. This variation in the exposure to the what to call sunlight, that is greatly influences the local temperature and causes the wind movements. Instead, the rotation of the earth is a reason for formation of the day and night. Instead, so to understand this, you are given to do one activity. Instead, here is an activity. Take a globe or a basketball. If your globe is not there, take a globe, focus the torchlight on that ball from some distance. So what do you see? From which direction you are focusing the torchlight on that ball, that area will be in a light, that is called day. And opposite to that part where the torchlight does not fall, that will be in the dark, that is called night. Another of part of the ball, that is globe, that we see that it is a night. Instant this activity, uh, do it at your home. Close your room, or evening 6 o'clock, 7 o'clock, switch off the lights. Then take a ball and use a torchlight on it. You will identify that in which direction you are touching. There, on some portion of the ball, you will see that torchlight falling. Then opposite to that place, you see that there is a shadow which is dark. So day and night, that is an illumination. So similarly, the sun, here we see that the sun illuminates one of the earth at any given moment. That means, look at my dear students, here we'll see that this is what to call area. I'll show you, my dear students. This is area here. This is exposed to the sunlight, right? This area exposed to the sunlight, and another area, this one is not exposed to the sunlight. So this becomes what, dark and the west side of this, it becomes what to call a day, right? So it is a light portion, and here it is we see that dark position. So the light position on this area is called day instant, and this dark position another side on the earth is called night instant. This changes at every moment instant because earth is rotating, right? At every moment it rotates. There is a movement in the earth's rotation at every moment, so that every part of the earth at every moment changes, right, in its rotation, so that the sunlight falling on the earth also changes at every moment. But we see that at every moment off of the earth, that means off hemisphere means it is the spherical shape of the earth. Half of the earth will be illuminated with the sunlight, and remaining half of the earth will be in the dark, right? So this is the what we see, that the sun illuminates one of the earth at any given moment. The edge of the sunlit hemisphere is called the circle of illumination. It is a great circle that divides the earth between a light off and a dark off. What I am saying here, my dear students, that is the edge of the sunlit hemisphere. It means that once again, look at here. I'll take you there the figure. Look at this. It is off area, right? So this off area is exposed to the sunlight, and that we call here great circle. This is a great circle. This is the great circle which dividing the off of the earth into the day, and remaining off is night. Look at this, the off part I am drawing here. This is the off part. We see that the sunlight is exposed, so it is day, and remaining off, this is not exposed to sunlight, that is a night instead. So that is called great circle, right? Up to here you find that it is littered with sunlight, right? As it is littered with the sunlight, this half of the part of the earth is called day. Another half where it is not exposed to sunlight is called dark half, that is night, my dear students. So what would happen if earth did not rotate on its own axis? As it is rotating, we experience day and night. When it does not rotate, what will happen? One portion of the earth which is to the opposite to the sun will get constantly heat and light. Another portion which would be constantly in cold and dark, right? This would make both portions unfit for life. How the life is surviving? For survival of life there is need of light, understand, right? That is not too much light, warmer light we need, understand. So if earth does not rotate, what would happen? Suppose you imagine that actually earth is rotating. This is the what truth. For if earth does not rotate, what would happen? Just imagine that what happens if earth is constant, it is not rotating. What happens? Only one portion, the half of the earth position will expose it to the sunlight. Okay, remaining off will not be exposed to sunlight, so that the part which is exposed to sunlight constantly will become what you call heat, and another part of the earth which is constantly in the dark will be cold. So too much sunlight and too much coldness on the earth's surface does not suitable to the life. So for life existence we need light. So earth rotates. So if earth does not rotate, what would happen? There would not be occurrence of day and night, right? First thing is that day and night will not occur, first thing. Second thing is that life may not possible on earth, right? Some part of earth will be in cold region, so people cannot live in the cold region, as in Antarctica we see, right? Remaining part which is continuously exposed to sunlight, that becomes heat and insolation receives much more, temperature also increases very much, so that is also not suitable. So the rotation helps the earth what to call to get heat and light constantly on a daily basis, right? On the daily basis, every part of the earth gets sunlight and becomes heat, right? This is needed. So the rotation of the earth is also one important factor for the existence of the life. If earth does not rotate, there won't be life. Understand? And there won't occur day and night. So you will be asked a question that what would happen if earth does not rotate? Then you should write that if earth does not rotate, then there won't be occurrence of day and night, and we see that the life may not possible on the earth, because both, that is too much heat and too much cold, these both are not fit for the water life. Understand? That is the water reason. Next, we will look into the water at tilt and revolution around the sun, right? It's the tilt in the sense bent, right? While it is earth, while rotating, earth always bent, that is 23 end of degrees. No, suppose you are playing coco or you are moving on the bicycle, right? What do you see at the turnings? You see that your cycle is bented, your cycle is bent, right? Or you are playing coco, then at a corner you have to bend to get the balance. So at every moment, earth is rotating on its own axis and revolving around the sun, so that it bends, that is 23 and of degrees. So the bend in earth's rotation and revolution is called tilt. So earth tilt and rotation around the sun also reason for change in the seasons, right? The earth revolves around the sun, right? Here look at this figure, I'll show you. This is the water figure. You can see here. Understand? The earth revolves around the sun while rotating around its own axis. That is, it spins like a top, and at the same time keeps moving forward around the sun. See, June 21st, here it is there. Then it moves to another place by March 21st. So that, what do you understand here? It keeps moving forward at every moment around the sun, right? The motion of the earth or the movement of the earth around the sun is called revolution, right? It takes 365 days and 5 hours 56 minutes to complete one revolution. Dear students, this is revolution. You look at, I am showing you. If earth starts here and comes to the same position here, right? This is called revolution, right? That means one revolution around the sun. This is the sun, my dear students. Okay, so around the sun it rotates, earth rotates, and also revolves around the sun. That is called revolution. And to complete a revolution, it takes 365 days 5 hours 56 minutes. It is nothing but 1 year. Each revolution takes about 1 year. Understand? This is the length of the year of the earth. Understand? So, how does this cause the formation of season on the earth, right? We have to find out that what is the relation between the earth's revolution and the change of the seasons, right? So, when earth revolves around the sun, there will be different places on different areas, right? Earth, when it is exposed to sunlight, then you will see that some part of the earth which is exposed to the sunlight is different when it goes to another part. Dear students, once you observe this figure very closely, you will identify here that I'll show you here. This is the place. What a tropic of a, this is where I'm tricking. The Tropic of Cancer, where the sunrays fall vertically, right? The next, when it comes to here, what that this December 22nd, Tropic of Capricorn, Tropic of Capricorn. Here also we see the sunrays fall vertically. So on June 21st, sunrays fall vertically on Tropic of Cancer, and December 22nd, the sunrays fall vertically on Tropic of Capricorn. Then coming to March, right? Here it is March 21st. You see that there the sunrays fall vertically on equator, the middle line, this is equator on March 21st, right? Similarly, then on September 23rd, we see that the sun rays fall vertically on equator, that is here, right? So there is a different positions of getting insolation at different places. That is called earth rotation and revolution will bring differences in its places observing the heat. Understand? So 1 minute and left. We'll finish in 1 minute our class.